750 light-years from Earth, in the Draco constellation, is possibly one of the strangest planets ever discovered. We're talking about TRES 2b, a gas giant slightly larger than Jupiter. If you were in a spacecraft orbiting this planet, most likely you wouldn't be able to see anything at all. It is the darkest exoplanet we know. Its ability to reflect light is not just low, it's almost non-existent, less than 1%. For reference, Jupiter, with its gleaming ammonia clouds, reflects more than 50% of the light that reaches it. This world is darker than coal, more black than acrylic paint, darker than any known object in our solar system. Science explains this phenomenon by the complete absence of reflective clouds in its upper atmosphere. Because of its extreme proximity to its star, about 30 times closer than Earth is to the Sun, it's too hot for ammonia clouds to form. Instead, the atmosphere is saturated with vaporized sodium, potassium, and gaseous titanium oxide. These substances absorb 99% of incoming light, turning the atmosphere into a dense barrier that prevents energy from escaping back into space. In such an aggressive environment, even the most advanced optics of your spacecraft would be useless. But this darkness does not equal cold. On the contrary, TRES 2b is a blazing sphere. The temperature of its upper atmosphere exceeds 980 degrees Celsius. Even inside a sealed vessel at a safe altitude, you'd feel the cooling system straining to fight off the intense thermal radiation penetrating the hull. And let's not forget the gravity of this planet. It is 1.5 times stronger than Jupiter's. Upon atmospheric entry, the resulting forces would rupture capillaries and cause internal bleeding long before the hull begins to deform. The gas density in the deeper layers is so great that your shuttle would slow down, as though moving through thick syrup. Your body would be pressed into the pilot seat with enough force for your bones to crack under their own weight. Onboard computers would begin issuing fatal errors as optical sensors fail to calibrate in zero visibility. You shouldn't expect to encounter any storms or bright lightning, only a dense and motionless mass that grinds any artificial object into a shapeless piece of metal. This world is terrifying, but it has an upside. It's predictable. We know its orbit, we know its star. This is a hell with a precise address. But what if you found yourself in a world with no cosmic home? What might occur on a planet drifting through the cold void for millions of years? Sometimes the laws of space simply cast their creation out into the void, as if discarding trash. There's a great example drifting through space 80 light-years away in the direction of the Capricorn constellation. We're talking about PSO J318.5-22, a planet that's only 10 million years old that was expelled from its star system during its formation. It has no sun, no orbit, and no sunrise. Modern astronomy often assumes that starless worlds are frozen blocks of ice, yet this orphan planet defies that expectation. Despite traveling for millions of years through the vacuum of space, with temperatures near absolute zero, its interior retains a fierce heat of 800 degrees Celsius. It's a gas giant with a mass 6 times greater than Jupiter's. It simply wasn't able to cool in isolation, preserving immense internal energy. If your navigation computer attempted to plot a course to this object, it would immediately throw out a software error. The systems responsible for positioning wouldn't have any stellar reference points in that sector to lock onto. Still, if you somehow managed to locate the giant, even the most courageous people would feel panicked upon approach. The ship's instruments would indicate a massive gravitational body ahead. Meanwhile, all you'd see through your viewpoint would be total darkness. What would follow is the fall into this invisible gravitational well. Upon entering its atmosphere, you'd encounter what scientists call infernal convection. There's no external heat source. All weather is driven solely by the planet's incandescent core. The inside of this world is ruled by eternal night, yet it's deafeningly loud. Studies indicate that the clouds here consist of molten silicates and iron. Immersed in this gaseous ocean, you'd hear a sound impossible to reproduce on Earth. It would not sound like wind. Instead, it's an unbroken, overwhelming roar of millions of droplets of liquid metal striking the titanium hull of your vessel. Yes, this is a world of endless rain composed of incandescent, lethal shrapnel. At a depth of 100 miles, neither spacesuit nor spacecraft would save you. Atmospheric pressure would transform gas into a superficial fluid, and your ship would not fall but sink into a searing metallic haze. Every breath would demand extreme effort, as if your lungs were attempting to move a slab of concrete. Your body would begin to collapse under its own weight before the hull finally ruptures. If this world terrifies you with its isolation and endless night, the next candidate embodies pure kinetic fury. Have you ever envisioned a world with the fastest planetary winds in the universe? Compared to them, even the strongest winds in our solar system would feel like a light breeze. In the depths of the crater constellation, there's an object adrift. While its official name is WASP 127b, astrophysicists call it a swollen ghost. This gas giant is a true anomaly when it comes to density. With a radius 1.5 times larger than Jupiter, its mass is only 1/5 of Jupiter's. In terms of density, it's akin to overheated cotton candy, stretched by the gravity of its star to unimaginable limits. But this apparent softness is deceptive. Heated to 1,100 degrees Celsius, the planet's atmosphere hides a kinetic fury that defies every known law of aerodynamics. On Earth, a Category 5 hurricane can tear down concrete buildings, and on Neptune, winds can exceed the speed of sound. Here, the very concept of a storm loses all meaning. In 2025, astrophysicists recorded atmospheric flows reaching 20,500 miles per hour, or 5.6 miles per second. This is an absolute record among all known planets. The wind here moves at 27 times the speed of sound. As fantastical as it sounds, it travels 6 times faster than the planet's own rotation. This is not simply moving air, but a wall of kinetic energy, behaving less like wind and more like a solid object. For reference, the fastest wind ever recorded in our solar system was on Neptune at 1,120 miles per hour, almost 20 times slower than the above. If you attempted to lower a probe into the equatorial zone of this world, it would cease to exist in an instant. At these speeds, atmospheric friction acts like a massive sheet of sandpaper. The hull would not simply be torn away, but vaporized. Metal would heat to plasma state in a fraction of a second simply from contact with this solid air. For a human present, even in the most advanced suit, death would occur before the brain could process pain. You'd be struck by a shockwave traveling at 5.6 miles per second, faster than the blast wave of a nuclear explosion. You'd not merely be torn apart, but reduced to a cloud of molecular dust that would continue racing around the planet indefinitely. There's no safe haven here. The entire planet is a continuous supersonic current. It's a world where the atmosphere itself is the most lethal weapon. Arriving here would mean instant destruction. You would likely feel nothing at all. The only world that may be considered more terrifying might be one that transforms into a blazing inferno within 6 hours, with no chance of escape. About 190 light-years from Earth, in the constellation of Ursa Major, lies an object that has turned its own orbit into one of the most extreme instruments of torment in the visible universe. This gas giant, HD 8606b, with a mass 4 times that of Jupiter, challenges our modern understanding of celestial mechanics. While most planets follow a relatively calm, nearly circular orbit trajectory, this giant moves along an exceptionally elongated and violent path. Its orbit resembles a thin, deadly needle piercing space at tremendous speed. For most of its 100-day cycle, the planet remains in deep freeze, retreating to a distant point and accumulating cold. But at closest approach, it plunges in a steep dive toward the blazing heart of its star. If you were aboard a ship following this giant, you would witness one of the most abrupt and violent climate shifts in our universe. Scientific models indicate that within 6 hours, the planet begins receiving 800 times more radiation and heat than Earth. Its atmospheric temperature surges from 500 to 1,200 degrees Celsius. Such explosive increase in temperature drives the gas to extraordinary velocities. Across an entire hemisphere, colossal shockwaves erupt, accelerating to 3 miles per second. This would sentence your shuttle to certain destruction from total thermal shock. The titanium hull would expand faster than the internal structure frame could compensate. Rather than roaring wind, you would hear the deafening grind of deforming metal and the sharp noises of rivets tearing loose as the craft split under extreme internal stress. Inside your suit, you would experience something akin to molecular roasting. Radiation intensity would be so extreme that the fluid in your eyes would begin to boil before decompression reduced the vessel to a piece of warped metal. This planet is an embodiment of an explosion, passing through a phase of thermal agony every 3 months before retreating again into cold emptiness. Out here, hell is a temporary and cyclical event that, in theory, one might be able to escape with a fast enough engine. Yet there are worlds in our universe where salvation is an option taken away by the laws of physics. If hell exists, it may be found about 200 light-years away in the Aquarius constellation. This is K2141b, a world that showcases how geology can be the most terrifying force in the universe. It's a rocky super-Earth locked in permanent tidal capture. One side perpetually melts under the star's scorching radiation, while the other remains in cosmic darkness at -200 degrees Celsius. The day side is not solid ground, but a global ocean of boiling lava hundreds of miles deep. Temperatures reach 3,000 degrees Celsius. While Earth has a water cycle, local nature has created a stone cycle. The heat is sufficient to vaporize granite as easily as the sun evaporates morning dew. Mountains turn into gas, forming a dense, suffocating atmosphere of vaporized quartz, sodium, and silicon dioxide. If your vessel entered these orange clouds, you'd find yourself inside a planetary engine of destruction. Supersonic winds reaching 3,000 miles per hour carry this stone vapor roaring toward the cold night side. There, the gas cools and falls again. Not raindrops, but a downpour of incandescent rocks and liquid stone. From the cockpit on the dark side, you'd hear a sound capable of driving any pilot to panic. Not wind, but a relentless barrage of millions of stones striking the titanium hull at supersonic speed like a machine gun. Your ship's multi-layer thermal shielding would be stripped away almost instantly by this brutal abrasion. The metal of the hull would thin under the barrage like paper against sandpaper until the magma below consumes what remained. Inside the suit, every rivet of your helmet would vibrate as life support systems struggle and ultimately fail under the external heat. K2141b is a planet that consumes itself in an endless cycle. It vaporizes its own surface only to hurl it back down again. If this world destroys itself from within through its own weather, the next one is demolished from the outside. We now move toward a planet that's practically being devoured alive. Imagine if our sun was not a source of life, but a hungry predator that had already started devouring its meal. At a distance of 1,200 light-years from us, in the star system of WASP-12, something very similar is taking place. An act of slow cosmic cannibalism. Before you is WASP-12b, This giant, whose radius exceeds Jupiter's by 1.8 times, is sentenced to death by the very fact of its existence. Because of its extreme proximity to its star, the planet completes a full orbit in just 26 hours, and most importantly, it's no longer a sphere. Gravity has stretched it, turning it into a deformed, blazing object shaped kind of like an egg. On the day side, temperatures exceed 2,200 degrees Celsius. If you found yourself aboard a ship in this star system, you'd be able to feel space itself vibrating with tension. It's not just heat, but the physical stretching of matter. If you were unfortunate enough to find yourself above the surface of this planet, the first thing you'd notice is the hull of your spacecraft constantly struggling against tidal friction, which would heat the vessel from within. From inside the cabin, you would hear a low-frequency hum, the sound of the star's gravity trying to tear the riveting from the hull. But the most disturbing events unfold in the upper layers of the atmosphere. The star is essentially siphoning gas from the planet's surface, forming a gigantic fiery tail between hunter and prey. According to scientific estimates, WASP-12b loses 6 billion tons of its mass every second. To grasp the scale of this consumption, imagine the Great Pyramid of Giza. Now imagine 1,000 of them, and every second that entire mass is ripped from the planet and pulled toward the star. The density of the atmosphere is so great that your ship would feel resistance even in the upper layers. If you attempted a maneuver within this stream, the vessel would enter a corridor of superheated plasma. The hull would not be merely melted, it would be stripped away by the star's powerful magnetic field, turning titanium plating into stellar wind in a fraction of a second. Inside your suit, you'd feel your organs shifting under the immense gravitational stress. It would feel like a slow execution by stretching. WASP-12b is doomed. Scientists believe that in about 10 million years, this act of destruction will be complete. The planet will be consumed without leaving a trace. To understand the scale of chaos in this world, one glance at its distorted shape is enough. Yet there are places in the universe that at first appear calm and even beautiful. That appearance is a deadly illusion, concealing something even more frightening. At a distance of 260 light-years from us, in the Sculptor constellation, hangs an object that astronomers initially mistook for a data error. This is LTT 9779b. If you approached it in a spacecraft, you would immediately have to engage the protective filters on the viewports, otherwise your eyesight might be damaged. This planet is officially recognized as the most reflective object known to science. It functions as a gigantic cosmic mirror, reflecting 80% of the light that reaches it. For reference, Earth reflects only 30% of light. But this beauty is a lethal trap. LTT 9779b is an ultra-hot Neptune, located so close to its star that it completes a full orbit in just 19 hours. Because of this proximity, the planet is permanently turned toward its star on one side, where temperatures exceed 2,000 degrees Celsius. According to the laws of physics, at this temperature, the atmosphere should be transparent, since any clouds would simply evaporate. Yet this planet makes its own rules. Its atmosphere is oversaturated with metal and silicate vapors. When these superheated gases rise into the upper layers, they condense, forming dense, shimmering clouds of liquid titanium and glass. These clouds create this dazzling mirror shield. In effect, these are true metallic clouds. Droplets of liquid titanium and silicates are literally suspended in the atmosphere of this planet. If you found yourself here, you'd enter a world of blinding brilliance and molten stone. Rain on this planet consists of liquid titanium falling from luminous clouds. Out here, your ship would not just melt, it would become part of this endless cycle. Even the strongest hull would be instantly consumed by this aggressive, abrasive material and vaporized in fractions of a second within this hellish furnace. LTT 9779b can rightfully be considered a world of chemical nightmare. But the next planet on our list looks something straight out of science fiction. A world shaped by a gravitational anomaly that seems to defy the very geometry of space itself. Surrounding it is a megastructure so vast, so colossal, that it appears almost physically impossible. J1407b is one of the weirdest planets scientists have discovered. Located about 434 light-years from Earth, this is Saturn on steroids. Studying this eerie world, astronomers struggle to measure its mass precisely, but it's believed to be around 10 to 40 Jupiter masses. J1407b is also a giant planet, much larger than the biggest planet in our solar system. What shocked scientists was the planet's ring system of enormous size. It consists of 30 rings, each the size of tens of millions of kilometers in diameter. According to rough estimates, the diameter of the entire ring system is 120 million kilometers. This is 200 times larger than the rings around Saturn. If Saturn had its ring system this big, it would dominate our night sky. But although this would have been a breathtaking view, it wouldn't last long. The rings would eventually become thinner as several satellites would form around the planet. But that's just the beginning. The universe has stored a lot more bizarre worlds for us. How can one planet be hotter than the Sun and the other one larger than its star? How is there such a thing as a marshmallow planet? And what are planets? We've prepared a list of the most mind-blowing worlds for you. One of them is an exoplanet located 57 light-years away from Earth. Dubbed GJ504b, it's 4 times more massive but has just about the same size as Jupiter. The weird thing about it is, it's pink, quite an unusual color for a planet. So how did it get this color? The system is believed to be roughly 160 million years old, a newborn compared to our solar system. And because of the exoplanet's age, it's still changing and losing the heat of its formation, which gives it a dull magenta glow. But our universe doesn't only come in electrifying colors, it also has a lot of water-rich planets. A Neptune-like exoplanet, or the water world, has a mass of more than 8 Earths and a radius 0.24 times that of Jupiter. And although this alien world may seem promising due to its abundance of water, it's no Earth twin. The planet doesn't have a solid surface, and its atmosphere drastically differs from the one we have here. Because of extreme pressure and heat, it consists of water in a strange plasma form that behaves differently from that found on Earth. Despite the fact that the temperatures there reach 280 degrees Celsius, water on GJ1214b doesn't have the usual vapor, liquid, and gas phases, but rather a constant supercritical fluid form. So it has some properties of both liquid and gas, but overall, it's neither and both all at once. Now let's move to the constellation Cygnus. There, about 650 light-years away, sits a scorching world, Kepler 70b. With a mass of just 0.44 Earths and a radius 0.75 times our planet's, this is one of the hottest exoplanets known to us. The planet star, Kepler 70, was once a main sequence star like our Sun, while Kepler 70b used to be a gas giant the size of Jupiter. But about 18.5 million years ago, the star went through its red giant stage. As a result of spending a significant amount of time inside its now dead star, a hot iron core of the planet is all that's left. Scientists think the planet is still evaporating, which could eventually make it even smaller. So how hot is it? Because Kepler 70b is 65 times closer to its star than Mercury is to the Sun, the temperature on this exoplanet reaches a mind-blowing 6,650 degrees Celsius. To compare, our Sun's surface is only about 5,500 degrees Celsius. So, if hell exists, it must be it. About 640 light-years away from us sits yet another scorching exoplanet dubbed WASP-76b. But that's not the only thing the planet's known for. It also has a permanent dark side and molten iron rains. Discovered in 2016, it's nearly as massive as Jupiter. Since it's tidally locked to a star, the planet faces it at all times. The temperatures on the day side reach 2,350 degrees Celsius. This is more than enough to cause metals like iron to evaporate into the atmosphere. Additionally, the radiation that the day side receives is thousands of times more than our planet gets from the sun. The dark side of WASP-76b is almost twice colder. Due to this extreme difference in temperatures, intense winds form on this exoplanet. Because of that, the iron vapor from the hotter part of the planet is carried by the wind to the colder side, and as this vapor cools, it rains molten iron. That's odd enough, but not as odd as the planet dubbed PSR J1719.5-22. But what's so impressive about it? This exoplanet is 3,000 times larger than its host neutron star. What's more, it wasn't always a planet. It used to be a star in the past. But let's start from the beginning. The exoplanet orbits an incredibly dense and tiny neutron star about 20 kilometers across. Only 1 teaspoon of this star's material would weigh billions of tons on Earth. The star is also a millisecond pulsar that emits beams of radiation while spinning every 5.4 milliseconds. This is about 10,000 rotations per minute. The star isn't lonely. It has a companion planet about 40% the size of Jupiter, PSR J1719.5-22. At the same time, this alien exoplanet is more massive than Jupiter. So how come it's so small and yet so massive? This is because the exoplanet was once a star whose outer layers were stripped away by a much more massive nearby pulsar. This left a carbon remnant of a star that became a diamond world about 5 times the size of our planet. It now has a diameter of roughly 60,000 kilometers, and because the exoplanet's proximity to the pulsar is very close, the whole system could fit within the diameter of our Sun. Space seems to be crowded with weird exoplanets, and some of them have properties so bizarre you could hardly believe these celestial bodies exist. Dubbed WASP-107b, this peculiar world has the density of cotton candy, which makes scientists revise their understanding of how gas giants form. While the exoplanet is about the same size as Jupiter, it's only 30 Earth masses, but Jupiter is 300 times as massive as our home planet. What's more, the core of WASP-107b is just 4 times bigger than the Earth's core, while it should be about 10 times that of our planet's. Because of all this, WASP-107b has an incredibly low density. In fact, it's like a marshmallow floating in space. So far, none of these worlds seem to be giving us any hope of colonizing them. But Gliese 581d could. Finding a planet that would be suitable for life is challenging itself, and it becomes even more so because of how far away most of them are. That's why Gliese 581d looks so promising. It sits well within 20 light-years from Earth and has a mass just about 6 times the Earth's. The exoplanet is in a habitable zone of its star, so the temperature could be right for liquid water on its surface. However, because it's tidally locked, one side of Gliese 581d is always warmer than the other. But it's not all that bad. Since carbon dioxide is abundant in the planet's atmosphere, it would keep the night side from freezing. While the Earth has its own regular day-night cycle and the majority of life forms here have adapted to live under such conditions, it's a big if the same could happen on Gliese 581d, given we colonize it one day. But if we do, the best idea would be to live in the region of habitability on the line that separates day and night, also called the Twilight Zone. The vastness of space is unimaginable, and 2-mass J2126 is living proof of that. This strange world was once thought to be a free-floating or lonely planet, but this celestial body isn't that lonely. It turns out that 2-mass J2126 moves through space along with a star, TYC 94869271. The weird thing is, both objects have been known to astronomers for years, but nobody saw the link between them. But then, scientists discovered the exoplanet and the star are both roughly 104 light-years from the Sun, which means they're connected. Later observations showed the planet orbits its star at a distance of 1 trillion kilometers, This is roughly 7,000 times the distance from our planet to the Sun. This makes it the largest orbital radius of any planet known so far. Interestingly, a result of such a huge orbit is that a year on this exoplanet equals about 900,000 Earth years. Now, let's get back to our solar system for a moment. The biggest planet here has 79 moons, so it seems logical exoplanets should have exomoons too. But for years, scientists haven't been able to find any, until now. Locating small cosmic bodies orbiting exoplanets is extremely hard. Nevertheless, astronomers have finally succeeded. But they didn't spot an exomoon. They found something even better than that. The first ever clear evidence of a moon-forming disk surrounding a huge distant exoplanet named PDS 70c. With the help of the ALMA telescope in Chile, scientists detected a disk in which satellites could eventually form, and its material is enough to make 3 of them, each about the size of the Earth's moon. For the first time in the history of astronomy, human beings could be observing how these small round worlds form in space, and not on a computer simulation, but live. The last exoplanet on our list is KOI 5AB, and what makes this one specifically unique is not its properties, but the system it's a member of. The planet about half the size of Saturn was first ignored because it was complicated and even considered science fiction. A decade later, the system named KOI 5 was given the scientific attention it deserved. It turned out astronomers stumbled across a triple star system. The planet revolves around Star A, which has a relatively close companion, Star B. They both revolve around each other every 30 years, but there's also a third gravitationally bound star, Star C. And this one orbits stars A and B every 400 years. If we could somehow travel to this exoplanet and hover on the edge of this world's atmosphere with our spacecraft, we'd be seeing breathtaking and unusual things. The bottom view would be most probably filled with dark brown and grey clouds, and instead of one sun, you'd see 2. One 17 times bigger than our star, and the other one quite smaller, and just about 0.5% as bright as our sun. But regardless of this, the fainter star would still glow 1,000 times brighter than the full moon here on Earth. No matter how unusual these alien planets are, there could be even stranger celestial bodies in our universe. So far, planets are usually hypothetical, but some scientists believe these could actually exist. If so, such mysterious worlds would form from the collisions of gas and dust particles surrounding black holes. These planets would also evolve at great distances from supermassive black holes, making their orbits million years long. The universe has no boundaries, not just in terms of distance, but also in terms of creativity. Now and then, astronomers discover mind-boggling space objects that broaden our limited imagination of the place we live in. It took us many years to discover all the planets of our solar system, and they're still surprising us with their properties. So who knows how much more eye-opening findings about the 5,000 known exoplanets are still ahead of us.